Okay. Okay, so welcome everyone, first of all. And before we are diving into the main topic, so I would like to take a few minutes to introduce our company, Pixel Learning, and what the services that we offer mainly. So I just share my screen here. Yeah. So Prabhat, the screen is
Yes,
visible now.
yes, it's visible.
Okay, thank you. So Pixel Learning, it's an educational research and training platform mainly, and we working in the field of higher education, mainly the technical educations, and we are dedicated to transforming the how like people can learn, give trainings, and conducting research, and what they are we working on that. Okay, so basically it's founded from 2018, and with providing the technical education services for the mainly engineering students also, and also for the working professionals. And we are offering services mainly starting from online courses, with the various online courses available for the softwares mainly, and also with the different of the topics like in structural engineering, mechanical, aerospace, and many of the fields. Okay. Second main, our service is for the live training programs. So it's on the two parts. We offering the live certification training programs, and we are offering the live placement based training programs for the
May
various of the job
sorry,
positions.
sorry to interrupt you.
Yeah.
Have you
Yes.
started the slideshow?
Yes. Yes. Yeah.
It's not visible to me. The slideshow is not working, I guess. PPT slideshow.
Okay. I just share the screen again.
Yeah, it was not changing. It was only one slide. The
Okay.
first.
Okay. 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 I just be there. Sorry to happening to all of you. Now it's visible.
Yeah, your screen is visible. You can start the power presentation. Let's see.
Yeah, there is a service slide here. It's visible?
No, your slide is not visible. Anybody can confirm whether I can just see your Google. Yeah, somebody is raising his hand. Okay.
Okay, not an issue. I will just explaining the things. Okay.
Yeah, the chat is open. I'm able to see the chat, but I'm not able to see your presentation.
Okay. 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 No issue. I
Go to
just
the
be
presentation. Yeah, go to the presentation.
yeah. It's visible now.
No, no, it's not visible.
Okay. No. Not an issue.
Share. Yeah, you can. If you want, you can just explain.
Yes. Yes. Yeah. I
Yeah.
just be explaining. Okay. So yeah. So we like offering service in the live training programs and all. Then after we are offer personal project assistance trainings and all on that. And the main thing is that for MTech and research projects also, we are be helping students to do the research on various of the softwares. Okay, and based on that, we are helping them to conduct the research on the particular softwares. We are also offering the corporate training programs and provide industry solutions on finite element analysis and all also. The four main of the expertise are in softwares that are in Abacus, Ansys, SolidWorks, SAP, MATLAB, LS-DYNA, Hypermesh, FEMAP, and many other softwares that mainly for the simulation software also, and also in analysis software that we have a core expertise for that. We are be connecting the fields that are for the background is for the civil, mechanical, aerospace, and automobile engineering also. And the industry that we are be covering are from the structural engineering, automotive industries, aerospace and defense, biomedical, oil and gas, also in marine engineering. So that kind of industry are we covering to offer the such kind of the services. Students access from our training programs from all over the global, from the diversified map, okay. From 50 plus countries, they are students from access our various of the training programs. The top countries are there from the India, US, Peru, UK, Egypt, Australia, Saudi Arabia, Bangladesh, and many others also. The main of the institutions that students can be accessed from our training programs are from the various IITs and NITs of the Indian education institutions also, and also from the state government and private institutions. From also world's top most universities can also be student can be access our trainings and all. You can check our Google reviews and all for the more informations regarding our trainings and what students can give the feedback on that. So based on that, you can be understand how and which of the levels that we are be of providing our services and all. Now, back to the main topic of today's webinar. Okay, so Mr. Prabhat is here, so he can explaining the all things about today's webinar. He has an industry experts in the 6 years plus experience in the industry domain to working with the simulations analysis part also, and hands-on experience in Ansys software. So yes, Prabhat, you can be start the webinar today.
Sure. Thanks, Mayank, for the introduction and then your uh, company information also. So let me start the presenting. Mayank, just confirm if it's
Hmm.
visible,
Yes, yes, it's visible now.
right? It's changing also, no?
Yes, yes, it's changing also.
Okay, fine.
Go ahead. Yeah.
So welcome everyone to this Ansys Workbench masterclass, which is on static structure simulation. Myself, Dr. Prabhat Kumar. I'm a Pixo educator here and currently working with some industry also. And I have done my PhD from IIT Bombay, India. So we will be explaining the workbench mainly, a workbench tutorial you can say. But before I go ahead directly and explain the workbench user interface and everything, I'll start with the basics of of the finite element analysis mainly. So the first question is like, why do we need the numerical analysis? So there are different uh, ways in which we can do the structural performance testing and all. So the structural analysis which is carried out, these are done to understand the behavior of structures when forces are exerted on them. Okay. So for any structural analysis, there are two key state variables. I hope you, since you all are from mostly from mechanical background, you must be knowing what are the two state variables which are any engineer or a designer they assess. So these are called stress and strain. Okay, and to determine those state variables, three methods are used. The first one we call it experimental method. The another one is called numerical methods, and the third one is analytical method. So experimental methods, these are the methods in which the design is manufactured in real life. Okay, and we test them, and based on the test results, we can you can say validate or calibrate our simulation models. But these experimental methods, these are generally standardized tests, and they're very time consuming, and they can be expensive to create and analyze. On the other hand, numerical methods, these are very simplified iterative algebraic equations which can be solved by a computer, and so that we can get the desired results. Mainly, a finite element method is used in analyzing these engineering problems because they can be easily implemented in computers. So in this session, we will be using mainly Ansys Workbench, which uses this finite element method to solve the engineering problems. But there is the third method also, which is called analytical solutions. And these are generally performed with hand calculations. Many of you might have taken this course in your undergrad, which is called finite element methods. So this is this analytical solution. So these are mainly available in structural mechanics theory, and here this is not the objective of our lecture. But these are exact solutions, and they can be found out for simple problems. While for the most of the engineering problems, it would be very difficult to be solved analytically, and hence because these methods are very complex. So in this session, we will focus on mainly on these numerical methods. In the next slide, we will specifically look how FEA this compares with the analytical solutions. So here you can see analytical method. Let's say there is a simple cantilever beam which is subjected to some load, end load at this end. So this is very simple basic problem. Okay, this you can easily solve it through the analytical method, finding the CL stresses, the bending moment and all, and deflection and everything. But let's say there is a complex structure like this, and you're applying a load over here. And then you want to measure out the stresses and the strain in this structure. Will you be able to do it through hand calculation, the analytical methods? The answer would be no. It is very difficult. It is next to impossible how you can obtain the stresses and everything. So for that, we use numerical methods, which is the either Ansys, or there are different softwares which are already available. Here we will specifically talk about Ansys. So through Ansys, you can carry out any type of problems, either simplified problems like this. Yeah, either the simplified problems or the complex problem also. Now let's expand our question, like why we use FEA. So this is generally two terms, FEA and FEM. So don't ever confuse with these two terms. FEM is the finite element method. It is the mathematical method which is used to conduct FEA. FEA is the analysis. And in this FEM, there are different partial differential equations which are solved to describe the physical phenomena. On the other hand, this FEA, these are performed using FEM, and it is implemented in computers basically, so softwares and all. So these are the tools which are providing basically a solution for the virtual prototyping. And the FEA helps to solve structural heat transfer, several types of problems very quickly, just by exploiting the computational power and making like we can make the design changes at very early stages of the product development. That's why we use FEA. Now FEA simulation, it enables us to innovation. Maybe we can explore the design through optimization, and we can generate multi-physics simulations. It also helps in cost reduction because we focus in virtual rather than on the costly physical testing. There are management of complexity in design and physics. We can improve the quality also, like we can validate our design and change it so that change it for different conditions so that we can ensure consistent performance. And there is a reduction in basically cycle time. So product to market time is getting reduced. If we talk particularly about Ansys, so most of you will be knowing Ansys is Ansys Incorporation. This is the company name, which is the developer of Ansys family of products. They have a range of products. The global headquarters is in USA, and they have various offices around the world. We will mainly talk about Ansys Workbench, which is a new generation solution from Ansys, and it provides like various interacting methods with the Ansys solver. So in this Ansys family, there are several types of you can say UIs and the modules which you can use. The first one is Workbench, in which you can observe the complete environment for simulation and modeling needs. There is Ansys CFD, which is computational fluid dynamics. They have different CFD solvers like Fluent, and there is also dynamic solver for transient nonlinear simulations. They have LS Dyna, which is explicit dynamic solver for simulating like crash testing, metal forging, stamping, and different types of failures. And they also have some meshing tools. So now Ansys, whatever modules which you have seen, they have applications in every sectors. So be it automobile, in defense, even in semiconductors and embedded softwares. That's why this is a complete package, and it is well known in the industry. So what we will particularly focus today, that is in Workbench. Now in Workbench, there are also different types of analysis which you can do. The first one, you can say it is a linear stress analysis, where you can be able to determine the deflections, the stresses, factor of safety, etc., and concepts under static loading mainly. Uh, there is also modal analysis, where you can determine the natural frequencies of the system, including the effects of loading on a already pre-stressed structures. So these are the different mode shapes which you can observe when you pre-stress any structure. Also, you can use this heat transfer analysis, where there is a steady state analysis, thermal analysis to find out the temperature field and the heat flux. Also, you can use Workbench for harmonic analysis, where you can determine what is the response of certain structures under different types of excitation. So this also you can easily be able to solve. So these are the different types of analysis which you can be able to get it through Workbench. We will I'll explain in actual Workbench also. But whenever you start, if you have Ansys Workbench in your laptop, whenever you will be starting launching Workbench, this is the general UI which gets opened up. Okay, so these are the different types of toolboxes, and as I have explained, there can be static structural, the modal analysis, everything that comes under this box. And whenever you click on this plus sign, it expands, and you can see what are the different types of things which are there. At any point of time, whenever you click on double click on any of these pointers, you will be getting that particular module gets opened up. And if you click on geometry, double click on geometry, this will open up, and then you can use whatever design model which is there. So when you start, as I've explained, after starting this Ansys Workbench, these are the analysis systems. So here you can see explicit dynamics, harmonic response, modal analysis. There is rigid dynamics also, and then there is a static structural over here. Transient structural is there. So all these are the analysis systems which is available. So before going into the actual analysis part, what are the major steps which is involved in FEA? So there are 3 steps. The first one is called the pre-processing, in which you define the problem. And then the second one is the solution, in which you assign the loads, the constraints, and you solve it. The third one is the post-processing, where you process and view the results. So in pre-processing, you define the key points, what are the element type, material, what are the geometric properties, what are the material properties, and then you mesh it. So what is meshing? Meshing is type of discretization. So if you have a big rectangle over here, and you discretize it into smaller rectangles, then this activity is called meshing. So the entire FEA is based around the meshing, because you mesh and then you apply the loading conditions, and then you get the results. So in the solution part, there are loads, the constraints, these are specified, and then you solve the resulting set of equations to get the desired results. In the results, you can observe anything, whatever point of interest you have, whether it is displacement, whether it is forces, or you can also get the stress contour diagrams and everything. So I'll start with the basic pre-processing of one Ansys example. So let's say this is the example, which is a simply supported beam. Okay, so it has a uniformly distributed load over here, and these are the reaction forces. And what you have to find out, what is the stresses and what is the deflection. So how will you do it? First, you start the static structural analysis. So this type of dialog box gets opened up. I'll do it live, and then I'll tell you that also. But before that, let's get an overview. So in this, when it opens up, there is the first thing is engineering data, and engineering data, it has the material properties. So When you will double click it, such type of box will get opened up. So by default, Workbench has structural steel as the default material. It has the properties which you can see over here, the density, compressive strength, and everything. So apart from this, there are different types of materials over here, which you can see. So these are the material properties basically. Uh, let's say that there is a whole library of material which is already available, and let's say that you are not finding a suitable material which is for your need. So how will you do it then? So for that, you can add a new material also. And for adding any new material, you need only two properties, basically density and the Young's modulus, the modulus of elasticity. These two properties are needed. When you feed them, you can have your own material ready with you. So the next part is geometry. In geometry, there are two options. Okay, so either you can create the geometry in Ansys design model or SpaceClaim, which is their own interface through which you can use it for designing purpose. Or the second one is you can design any geometry in your software which is of your interest. Let's say you can design it in SolidWorks, you can design it in Creo or anyone, CATIA, anywhere, and then you can just import it. For importing, you have two formats. You can use IGES or the step only. So this is the example, the simply supported beam. So this is designed in design modeler. Okay, so I'll explain that also later on. After this material, the third part was you click on the model. Okay, once you click it, such type of dialog box will open. Here you can see you have geometry, you have the coordinate systems, you have meshing, and here analysis settings, and everything will be there. Okay, so you click on the geometry and then you can see like what all material you have given, is it coming or not over there. After seeing this, what you have to do is you have to mesh it. So this is the mesh. You have to click on mesh and such type of box will open up. Here there are different options like sizing, what size you can use, the coarse or whatever fine, what type of smoothing is needed, what is the element size. So by default it is taking as default. You can click over here and you can change the element size of your meshing also. But there is a whole one lecture which needs to be delivered for this meshing. Meshing itself is a huge like task. Here you can see different types of methods are there which is there in meshing. But I'll go with the basic one, and the detailed for the detailed description of this meshing part, maybe we will cover up in the actual course one. So this is the meshed beam which you are seeing. The next part is boundary conditions. Okay, so first boundary condition is you have fixed support over here and you have a rolling support over here. So for that, you can just click on this right click on this static structure and you can insert this supports. Okay. The next is after applying the boundary condition, you have to apply the loading condition, like what all loads are there. So for, let's say we are applying a load of 5 kilonewton. So this is the type, and then once you apply the loads and everything, you do the post processing. You just solve it, and after solving, you get the results. So that simply supported beam that has a stress value of 58 megapascal. This you can compare it with the yielding strength of the material, and you can see what is the basically it's a factor of safety. That also can be easily calculated through Ansys, like Workbench also. You can also observe the deflection. Here you can see what is the deflection. It is around 1.2 millimeter. So through this you can cover up the entire a basic overview of Ansys Workbench. Okay. Now let me show you the exact UI. So here you can see this is the user interface when you will open. Okay, this will not be there. This static structure, this will not show up. How it will come when you will right click on this, either right click double click, or you can just pick it up and place it over here. So that also works. So after clicking the static structural, such type of dialog box you can see. So as I have explained, you have engineering data. Okay. So in the engineering data, you can see different types of materials are there. Here is the engineering data source. Here you can see what are the materials. So air, water, liquid, like a lot of materials are there. Here you can see there are geomechanical materials, there are composite materials. So everything is there. So this you can use, just you can click on this epoxy and you can add it, it will be added. And then you can go to your project. So for now, I have not selected any material. By default, it will take structural steel as the default material. So after that, what you have to do is you have to import your geometry. So for geometry, I have already explained there are two ways. So first method is you can go and you can design your own geometry in the design modeler or the space claim, and the second one is to import it. So for creating, just right click, and here you can see. So since I have already opened up this design modeler, it is asking for edit geometry in design modeler. But when it is not opened up, here you will be getting the geometry in design modeler, and you have to click in design modeler. So once you click in design modeler, such type of user interface you will get. Okay. The very first thing which you have to do is you click on the units and make as per your requirement. So somewhere it is inches, somewhere it is meter or millimeter. So we will go with millimeter. Okay. So here you can see these units are displayed over here. Now in design modeler, there are two modes. Here you are able to see sketching and modeling. So these are the sketching module which we will use. And let's say I'll just go and explain you the normal. Let's say we are making a normal rectangular plate with a hole. So how will we do? We'll just click on the sketching, and then we click on a rectangle. Let's say the rectangle. Before clicking on that, here you can see it is in 3 dimension. Okay, and you have to it is XYZ plane basically. Now what you have to do, you have to click on this look at face sketch so that it will be perpendicular, and then you can go on rectangle and you can draw a rectangle like this. Okay. Now it has been drawn. You have to provide the dimension. So just click on the dimension and click here these 2 dimensions that we need. So here it is by default it takes h1 and v1 or v2. So h1 is this one. Let's say the rectangle is of 50 by 50. Sorry, square is of 50 by 50. So you click on 50, then you double click here, make it 50. So it is a square. Okay. Again, you go on draw. Maybe we will draw one circle. And then again, go on dimensions. You can give dimensions to this. Let's say it is of 20 millimeter of diameter. Okay. Once you draw it, what you have to do is you have to extrude and click on this generate. Now you can see. So this is the small square plate with a hole, center hole in this. So what you can use is you can go here and then you can just open the model part. So when you open the model, the one part that you have created in design model, that will gets opened up in the actual model part. Okay, it will get it automatically opened up. But since let's say that we want to just import our already saved file, which is there in some IGS format. So then we can go on geometry. I'll show that also later on. And then we can import it from there also. So let's give it a little bit of time so that it gets opened up. Yeah. So here you can see this is the interface of the mechanical workbench. It is still opening up, so we will be able to see. Yeah. So this is the part that we have already designed. Here you can see the geometry. It is a solid. Then material, you can see structural steel. It will take it by default. Structural steel. It has the following material properties: Young's modulus, the Poisson's ratio, everything. And then what we'll go on meshing. Okay. I think it is still opening up. So this was just an example which I was showing, in which how you can use the design modeler part. Okay. In Ansys, what you have is you have two different modelers which you can use. Okay. Now I'll just close it. So, and I'll open the actual one, the leaf spring part, which I'll be explaining. Yeah. So for that, see, this design modeler which I have just shown right now, that is good, but for easy parts, not for complicated parts. Let's say you have to make some gears or some big complicated parts which has different geometry, shapes, and all. So then you will not be able to use it because it is not that user friendly. So for that, what we do, we just create our own model. Let's delete this. Then I'll just drop it over here. So for geometry, we can design our geometry in any SolidWorks software, anywhere, and we just click on import. Okay, you can browse, and then let's say whatever file you have made, you need to just save it in IGS format. Okay, make sure that you have saved in IGS format. Okay, and then you can open it. The geometry is open. Just double click on model. Okay. So meanwhile, this model is getting opened up. As I have already mentioned, there are two different modules, or you can say two different modelers in Ansys. The first one is called design modeler. The second one is called space claim. Okay, so design modeler was the only modeler which was provided by Workbench until they were using Ansys 15 version. So for simple small models, design modeler is well enough. Okay, but not for complicated large models. So in Ansys 16 and 17 onwards, the space claim was this was included in Workbench. So here you can see this is the leaf spring design. So you can design it anywhere, and then you can save it in IGS, and the way I have shown, you can import it. When this is the user interface, when you get over here, the first thing you have to check is this one, metric. So make sure that your metric is kg, this one. Okay. So this is the geometry. So since there are 4 parts, it is showing the different parts also. See here, you are seeing contacts. Okay, this is another part which is of very much importance. Let's say you are making some bodies which is consisting of 2-3 different parts, and then how you have to do it. Okay, yeah. So these are the contact regions basically. I think some of the module is missing because I'm not able to. Okay, fine. So these are the contacts which is there. Now contacts will be of different types. Either it is bonded contact, or it is friction contact, or anything. So based on that, the contacts are defined. So you can go and you can define your own contact in this Ansys. So that is a very good provision which is there in Ansys Workbench. So for now we will not look into any contact. What we'll go is we'll go with this meshing, and now here you can see mesh, but I guess okay, yeah. So these are the different geometry which we have to mesh. Okay, so it is asking for sizing and all. Okay, so what is the element size? Let me close it. I think there is some issue with that. So meanwhile, I'll just open it up. I have some questions. Okay, Mayank, I'll ask you to see what are the answers that people are giving. So the question is, what are these mandatory material properties which is needed for static structural analysis? Okay. So I have given this. Can you let me paste it over chat box so that it will be easy, because yeah. Is it there in the chat box, Mayank?
Yes, yes, yeah.
Okay, so you can try, anybody can try and answering it. Meanwhile, I am opening this.
Okay, yeah.
Any
So
answers coming
everyone,
up?
it's not possible to maybe write on chat, but you can add your answers on a question answer.
Yeah, sure. So generally it takes a little bit of time to open up properly. Yes. So here we are. This I have already solved. So I'll explain. Once you are, yeah. So let's start again. So here we are seeing this is the different parts like geometry. When you click on geometry and materials, you'll be able to see what are the different types of material. You have to go on the meshing part. So when you click on mesh, this is the dialog box which is there. So just keep it for default, and what you have to do is you can change the element size. Let's say we are putting 10 as the element size. Okay. Once you click on this, just update the mesh, and it will be ready. So here it is. Here you are able to see meshing. See how coarse the mesh has become now. Okay. So it is always better to go for finer meshing to get better results. So let's go for 2 of mesh and we will update it. Yes, so this is the mesh. You can go for 1 also, 0.5 also, that is there. But the finer the mesh, the harder, or you can say the time consumption becomes more and more. Okay. So after meshing, what you have to go? You have to go on this uh, uh, static structural part, and you have to assign the supports. So in leaf spring problem, let's say you have given the problem as these 2 points, these are fixed, and we are applying a load at this bottom part. So for that, what you have to go, you can go on a static structural, you can go on insert part, you can go to fix support. Okay. Let me delete this. I'll show you right away. So what we will do, we'll go on insert, fix support, and then you have to click on the faces. So here there are different options. Either you can click on vertex, or you can click on edge, you can click on face also. So for easier part, we will go and we click on this face. Once you click over here, then you can go and click at this part. Since we have to select this face also, just press on control button and select this part also. And then you can go for apply. As you will apply the fixed supports, it will become like this. Here you are seeing blue colors and at these 2 points. Okay. Now let's say after this is the boundary condition. The next step is the uh, loading condition. So for that you have to go and insert different types of loads are there. There is pressure, there is force, there is remote force, there is displacement also. So it depends on the nature of the problem, like what is the problem which is given to you. So we will go with force one. Okay. And then again select on this face. It will ask, this is the part which you have to see. It will ask for scoping method, which is the geometry selection, like which face you have to apply the force. So let's say this is the bottom part and you click on apply. Now the force is applied, but you have to provide the magnitude also. So for that there is option which is defined by. Okay. So here you can see there are two options, either vector or components. So what you have to do, you have to click on components, because there are three different components which you are seeing here. This is the coordinate system, x, y, and z. So let's say the problem was that the load is applied from this way, okay, from down to up. So in that case, what will be the coordinate? Y coordinate. So x and z, you have to keep it as 0. You just provide the y component. Let's say it is 100 Newton. Now see, as soon as you put 100, this is the arrow which is coming up. It means the load has been applied. Then you have to go on the solution part. Here the what you can say, the problem is defined, and now we have to solve it. So while solving, you need some results. So it depends upon your requirement. What is your requirement? First one will be, let's say, deformation. So you can go insert deformation, total deformation. Okay. Then you can also go and you can see the stresses. What is the stress? Okay. So let's say we are, as of now, we are interested in these two results. So you just input these results and just solve it. Okay. When you will solve it, it will take some time in solving whatever, based on your computer capabilities and all, and it will solve and give you the results, like what is this total deformation and what are the stresses. So it is, here you can see it is building the mathematical model. So on the back of this modeler, all the calculations are going on, and based on those calculations, it is solving and trying to fetch the results for you. Now it is evaluating the results, and here you are done. So when you are seeing this red color, it means it has the maximum deflection. What is the maximum deflection? It is around 0.006. You can play and you can see how it is deflecting. Okay. So this is the deflection. And when you click on stress, so the maximum stress is around 42 megapascal. So that also you can check what are the regions where the maximum stress is happening. So these are the regions where there is maximum stress, which is the boundary condition where you have fixed the point. That is the point. Okay. So let's say the deformation which you are seeing, see, it is showing that it is large deflection which is going over here, but the value is very, very less, 0.006 mm. So in that result part, there are options, different options. Okay. If you click on this true scale, this is the actual scale which is happening. Okay. And when you play, you will not be able to see any deflection, which is the actual one. Okay. So in the previous one, it has exaggerated by some times. Okay. That's why you are able to see. So actually in true scale, it is very less, the deformation, and which is right also. It is hardly 0.006 mm. So you'll, by naked eye, you will not be able to observe it, the effect. Okay. So this is the simulation. Let's say we are applying a force 100 Newton we applied. 100 Newton is hardly like 10 kgs. So let's say we increase the force to 500 Newton. As soon as you increase, here you are saying you have to again solve it. So it will again, the solver will run and it will try to fetch out the new results based on your inputs, and then it will solve the simulation. So earlier, what was the result? 0.006. Now it has increased by 5 times. So it is not always linear. Yeah, here we are true scale. Let's say this is the scale. Now you can see the deflection. You can also see the stress. What is the stress? Just 213 megapascal. Okay. Let's say you want to see what is the factor of safety. So for that, you can click on this insert and then stress tool. And then again in stress tool, just click on this plus button. You will be able to see safety factor. Since we have included it not right now, it has not been calculated. So just you have to solve it, and then here you are able to see. See what are the results. The minimum is 1.16 is the factor of safety. So at some points, the factor of safety is 1.16, and that is it is for red party, not even red. So the brown ones mainly, or the yellow ones. So let's say we increase the force and then we try to see what is the effect. So we'll increase the force and then solve it. So structural steel, as most of you are mechanical engineers, you must be knowing it has yield strength around 200 megapascal, 200 or 210 probably. But when you click over here, the stress value is 427 megapascal. It means it will go in yielding, and based on that, the factor of safety you are able to see it is 0.58. So it means the design will fail. Okay. So here you are. Let's say our stress value, it is 400 megapascal. The deformation is 0.06. Let's see how this meshing will affect the results mainly. So it was, let's say we have given 2 mm. Now we will go for probably 1 mm. Okay, and just change it to 1 mm. Update the mesh. It will update all the mesh. Since the mesh has been updated, the solution will change. Okay, earlier it was 0.06. Now you again have to solve it, and then you just see how the meshing is affecting the solution part. We will solve it and we will see. And see, it is 0.06 only, but it was earlier it was 0.060 something. The stress was 420 or something around that. It has increased now. Okay. So then the question might be there in your mind that how will we identify what is the perfect, or you can say the appropriate mesh size for any such, you can say, simulation or analysis. So for that also there are different types of analysis which is there. You can go for convergence analysis and you can converge to a particular mesh size. Beyond that, even if you are changing the mesh, it is not going to affect your simulation results. So that is the ideal mesh size for your case. Okay. You can observe what are the different types of results which are there. Yeah. So that's all for this session. Maybe, Mayank, we can ask for any question answer if people are having.
Yes, yeah. So I already made the contributors request to send all of you. Okay, so you can be accept it and you can unmute yourself and ask your question also. So yeah, Imrul, Mohammed, Rahul, Salman, Jayshree.
Anybody having any question, any doubt, you can ask us. Yes, Swaibu. I hope I'm pronouncing it right, you can ask. Hello? Hello?
Hello, how are you?
Yes, yes, I'm good. I'm good. Say,
Good evening. I'm Swaib from Uganda.
okay,
Um, I would request
go ahead.
maybe I don't know. It was maybe network. There are some
No,
points
no problem.
of the lecture that maybe because of network, like they were freezing. So maybe I don't know if you would share the recorded version,
Sure, sure,
and uh, and I would really be grateful.
sure, sure. The entire lecture has been recorded, and I hope Mayank
Yes, please.
will share that with everyone, so
Yes.
you can watch it later on also.
Hmm.
All right. Thank you very much. Cheers.
Yes, thank you. Salman is asking for the geometry file and the video. So geometry file, I'll share that with Mayank. He will share the geometry file as well as the video file for your reference. And maybe if you want, you can ask questions maybe later on also through some mail or whatever. I think Mayank will feel right. Yeah, you're welcome. Anybody else? Any question?
Uh, I'm Leon from
Hi, hi,
Bangladesh.
Limon. Say
Uh, Thank you for your nice presentation.
thank you.
I'm actually new in Ansys software.
No problem. Yes.
I need to know what are the limitations of using student version of Ansys software.
Uh, See, student, whatever demo that I have given to you, that was in student version itself.
Yeah.
Okay. So per se, if you'll ask, there is not that much of limitations if you're handling for smaller geometries and smaller mesh sizes. Okay. It will create issues when the mesh size is getting too much to handle. Okay. But
Okay.
for simpler geometries, I don't feel that there is much issues with the soft student version. You will be able to carry out most of your uh, analysis and simulations using this.
Okay. Nice. Is there any expiry date of the student version?
uh, I have no idea about it. I'll check and get back to you. Okay. But it was not showing. See, I have also installed earlier. I was using the licensed version, but yesterday itself I installed the student version also to see. But it did not prompt any you can say expiry date or something to me till now, and not even during the installation. So I have not clarification regarding what is the expiry date, but you can search about it. Okay.
Can I install the cracked version of Ansys Workbench?
We don't what you can say, we don't encourage such type of things, Mayank.
Yes, so that you can be install any versions available on the internet, but we recommended to use only student version, authentic version that offered by the company only.
Uh, okay. Thank you.
Yeah.
Student version is okay. You do not need to worry about it. Okay.
Okay. Thank you.
And also,
Anybody?
like we have the one live certification training programs on Ansys Workbench. Okay, so I will send the more details with you, and I will send the link here so that you can be check that. On that, we'll cover all of the most analysis on the software, so that you can check the details on the link and you can fill up your form. So based on that, we'll communicate on that.
Anybody else having any queries, you can ask. Else,
Will
Mayank,
the
yeah,
will
go ahead.
the course be started from the very basic of Ansys?
Yes, yes, basics, starting from basic, going in depth of that, all the analysis part, and you can say that mainly we will cover up structural, static, as well as dynamic, like transient structural, modal analysis also. So you can check the link which Mayank has put up over there. All the types is already explained. What are the different types of analysis that will be getting covered in that?
Actually, I need to learn Ansys software for applying it biomedical side.
Okay. So will you be using to analyze? Like what are the results that you are looking for?
Uh, Actually, from CT scan or MRI file, I will develop a model of any anatomical part of our body,
Okay.
and the 3D model will be developed using Rhino or SolidWorks software, and
Okay.
this model will be used in Ansys software. And finally, I will develop another model of footwear,
Mm-hmm.
and plantar pressure distribution will be measured using finite element analysis method.
So basically, we'll be measuring the plantar pressures and all, right?
Yeah, plantar pressure. Yeah.
Okay, okay. So see, for that you'll be needing whatever CT data and all what you are getting. You just need in SolidWorks. You just convert it into IGS. Then you can easily import it in ANSYS and you can do the analysis. Pressure distribution. I guess that is the major target for
Yeah,
you,
yeah,
right?
yeah.
Yeah,
Pressure distribution.
yeah. So that is easy. That you can easily done. You'll be able to do it once you learn all the parts, no, all the analysis types. You can easily do it.
Okay. Thank you. When will your course be started?
Mayank,
The first
Mayank,
first week of January.
First week of January. And how many live classes will be occurred in every week?
Yeah, that is around 5 days on per week. So that is 5 class on a week. It's around 3 week around. So around 15 plus classes that we have. For more information, you can be visit the link and download the syllabus also from that. And yeah, we can communicate on personal also about your doubts and all.
Okay.
Anyone else? Okay, then uh, you can later on connect with us. Okay, if you have any doubt and questions, we send all the recorded full video for this webinar and the geometry file of the model in your mail ID also. And you can visit our websites on that so that you can be check out our courses and all available so that you can be enroll on it if you need it. I think all things to be clear now, Prabhat, so that
yes.
we can close this webinar.
Sure, sure, sure. Okay. Thank you, everyone.
Yeah. Okay, then. Thank you so much, everyone, for connecting with us. Yeah. Thank you so
Bye.
much. Yeah.
Thank you.